Okay, people, good evening and welcome back to Electric Circuits. You see, in the last session, we dealt with mesh analysis, yes or no? In the last session, we did mesh analysis. Before mesh analysis, we also studied nodal analysis. So, these two analysis methods, that is nodal analysis and mesh analysis, they are the two most basic methods of circuit analysis which can be used to analyze any circuit. Okay, now we shall look at the concept of linearity. First let's talk about linearity in general. See, we will talk about linearity in the context of what systems first. That is what linear systems. All of you must have heard about linear systems. So what is any linear system? Any linear system is what? One in which the outputs and the inputs are linearly related to each other. I'll say it again. Linear system is one in which the outputs and the inputs are linearly related to each other. Such a system is called as what? A linear system. Okay. So simply put, what is a linear system? Linear system is any system whose output is what? Linearly related to the input. Output linearly related to the input. It means what? Output is actually proportional to input. This is the property of any linear system. In any linear system, output is what? Simply proportional to input. This is the only thing you should know about any linear system. What is it? The fact that output is what? Proportional to input. So let me write output, it is what? Linearly proportional to the input. So the same thing can also be written as output being linearly proportional to the input. So in general, you represent any system with a box, yes, and for the box on one side we have the inputs and on the other side we have the outputs. Okay, let's say for this box, the input is what? Applied on the left hand side. If you look at this arrow mark, it is what? Pointing into the box. That means what? The signal is applied to the system. Okay, what signal will be applied to the system? It is the input signal that will be applied to the system. Usually for any system, the input is what? Denoted by X, and for any system the output is what? Denoted by Y. And if this system is what? Linear, then Y will be proportional to what? X. Now if Y is what? Proportional to X, now to get rid of the proportionality and so on, you can introduce some constant of proportionality and you can say that Y equal to what? Kx. That's all. There is the input output relationship in any linear system. Output is equal to what? Some constant multiplied by the input. Now we will extend this definition of linearity to a more general case where the system can have any number of inputs and any number of outputs, because in this example for this so-called linear system, there was only one input X, there was only one output Y, and because it's a linear system, Y is what? Proportional to X. But in general, any system can have any number of inputs and any number of outputs. Okay, so let us consider a system which has got 3 inputs and 2 outputs. What is it? We have a system that has 3 inputs and 2 outputs. Okay, look at this. So obviously the 3 inputs are applied at 3 different locations. Let the first input be X1, let the second input be X2, let the third input be X3. So what are the 3 inputs to this system? They are X1, X2 and X3. And as I already said, let there be 2 outputs for this system. So what are the 2 outputs? Y1 and Y2. So what are the 3 inputs to this system? X1, X2 and X3. And what are the 2 outputs of this system? Y1, Y2 and Y3. Now if I say that this particular system is what linear, if I say that this particular system is what linear, let me write it. So let us say this is what a linear system. Now already you know the property of any linear system is what output and the input are linearly related to each other. So in this case, because you have multiple inputs and multiple outputs, every output, each and every output, that means what y1 and also y2, both the outputs will be what linear combinations of the various inputs. In a linear system that has multiple inputs and multiple outputs, every output will be what some linear combination of all the different inputs. Let me write that statement so that you can keep it in your mind. In any linear system, every output, what is it? In any linear system, every output will be some linear combination of the various inputs. Okay, every output will be some linear combination of the various inputs. This is true for any linear system having any number of inputs and any number of outputs. Every output will be what some linear combination of the various inputs. That means y1, which is what one of the two outputs, it will be some linear combination of x1, x2 and x3. All of you know the meaning of linear combination, right? So y1 equal to what? Something times x1 plus something times x2 plus something times x3. This is the meaning of y1 being a linear combination of the various inputs. There are three inputs in this case, x1, x2 and x3. So y1 is what? Linear combination of x1, x2 and x3. In the same way, even the other output, that is what y2, will also be some other linear combination of the same three inputs, x1, x2 and x3, which means even y2 can be written as what? Something times x1 plus something times x2 plus again something times x3. So every output will be what? Some linear combination of the various inputs. This is true for any linear system. So both y1 and y2 are what? Linear combinations of the three inputs x1, x2 and x3. So if you want, you can assign a name for the various multiplying factors for the different inputs. Like if you take the first equation where y1 is what? Something times x1 plus something times x2 plus something times x3, you can write this constant as what? Some k11, k12 and let this be some k13. Okay, and even y2 is what? Some other linear combination of x1, x2 and x3. Even here you can write y2 is what? Some k21 times x1 plus some k22 times x2 plus again some k23 times x3. So in this way you can introduce some appropriate constant of proportionality. Okay, so is it clear the idea of a linear system where the output is what? Linear combination of various inputs. Before this we have just looked at a very simple case where the system has got only one input and one output. One input x, another output y. Y is equal to what? Some k times x. But this is what? But this thing is what? The more general case where we have multiple inputs and multiple outputs. I hope this is clear. Okay. Now let us say there is some system for which there is one input x and there is only one input y, and let the output input relation, that is what? Relation between y and x, be something like y equal to what? Mx plus c. All of you know this, y equal to mx plus c. It is what? The equation of a straight line, and straight line is what? It's a linear thing. yes or no? So y equal to mx plus c, that is the relation between output and input. So given that this is the relation between output and input, is this system linear or not? Okay, let me write it. Is this system whose output input relationship is what, like this, that is what, y equal to mx plus c, going to be linear or not? Is this system yes, please type in the chat box, is this system linear or not? Is this system linear or not? Just say yes or no, then we'll take it from there. Okay, no, that's correct. The system, even though the relationship looks like it is what, linear, because I already told you y equal to mx plus c, it is what the equation of a straight line, and straight line in general is what, treated to be linear. Okay, but this system, it is actually what, non-linear. Now let me explain why it is non-linear. Okay, you see, the fact of the matter is what, all linear systems obey something called superposition. I'll say it again, all linear systems obey something called superposition. Let me write it on a different page. What is it? All linear systems obey superposition. In fact, if you want to test or if you want to find out whether any given system is what, linear or not, just check if that system obeys superposition or not, because all linear systems obey what, superposition. So if the given system obeys what, superposition, then it is what, linear. But if the given system does not obey superposition, then the system is what, not linear, or you can say it is what, non-linear. Understood, right? All linear systems obey superposition. So in a way, superposition is what, the test of linearity. All linear systems obey superposition. So indirectly we can say superposition is what, the test of linearity. Okay. So the other way to convey the same message about a linear system is what, that superposition, it is what, a test of linearity. So if you want to test or find out if a given system is what, linear or not, just verify if superposition is what, being obeyed or not. If it is being obeyed, then it is what, linear, otherwise it is not linear. Now what is this superposition? What is this superposition? You see, let's say there is this system for which when we apply an input x1, there is some system, whether it is linear or not, that is secondary, but we got a system for which when we apply an input of x1, the resulting output is what, some y1. So there is some system and you apply some input x1 and you just find out what the output is, and the output turns out to be y1. Now take the same system, apply a different input, let it be x2. So obviously when you apply a different input, you would also expect some different output, let it be y2. So there is some system for which when you apply x1 as the input, the output is what, y1. And for the same system, if you apply a different input, say x2, the corresponding output is what, y2. Now again take the same system, and apply an input which is equal to what, x1 plus x2. What is this x1 plus x2? Is it not the sum of the two previously applied inputs to the system? x1, the output is what, y1, x2, the output is what, y2. Now the applied input to the same system is what, x1 plus x2. In this case, let the resulting output be denoted by y3. You understood? So when you apply an input of what x1 plus x2 to the same system, let the resulting output be some y3. Now, if this system is what linear, it will obey what? Superposition. Now, what is that superposition? When the inputs are added, even the two outputs will get added. In other words, if this system is what linear, then y3 must be equal to what? y1 plus y2. Understood? So if this system obeys superposition, then when we apply x1 plus x2 as the input, even the output will be what? y1 plus y2. y3 will be equal to what? y1 plus y2. So what you can do is take the system, apply x1, find what the output is, let it be y1. For the same system, again apply x2, let the output be y2. Now when you apply x1 plus x2 to the same system, and if the output turns out to be y1 plus y2, which is the sum of the two previous outputs, then the system, you can say it is what? Linear. So in this way, you can easily determine if any system is what? Linear or not. I hope the meaning of superposition is clear, and also how it can be used to test if any given system is what? Linear or not. So with this in mind, let us go back to the previous system, for which output is what? Given in terms of input as what? Y equal to mx plus c, and we would like to know if this system is what? Linear or not. So what you have to do is to test if this system satisfies superposition or not. Okay, is it not like this? So take the system, apply some input x1, let the resulting output be some y1. So what is y1 in terms of x1? You know y equal to what? mx plus c. So all you are doing is what? In place of x, we are applying x1. So here also in this equation, in place of x, you should write x1. So y1 will be what? mx1 plus c. Again take the same system, you apply a different input, let it be x2. Let the corresponding output be denoted by y2. So what is the output going to be? See, in general, y equal to what? mx plus c, and here x is what? x2. Simply in place of x, you write x2. y2 will be what? mx2 plus c. So these are the two outputs in the two cases when the inputs are x1 and x2 respectively. Okay. Now again, you take the same system. This time you apply an input which is the sum of the two previous inputs, that is what? x1 plus x2. Okay, and let the resulting output be denoted by y3. In fact, this y3, will it not be equal to m times the input plus c, mx plus c? It means what? M times the applied input plus c. What is the applied input in the third case? It is x1 plus x2. That is what? M of, or m times x1 plus x2, and then plus c. Now if this system is what? Linear. If this system is what? Linear, then you know this y3 must be equal to what? y1 plus y2. That is what is superposition. Let's find out if this actual output is indeed equal to what? y1 plus y2. If it is equal to what? y1 plus y2, then it obeys what? Superposition. You can say the system is what? Linear. But if y3 turns out to be not equal to y1 plus y2, then it does not obey superposition, and you can say the system is what? Non-linear. Okay. So already we know what y3 is. What is y3? m times x1 plus x2 plus c. Let me write the expression for y1 plus y2. This is what? y1, this is what? y2. What do you get when you add y1 and y2? Won't you get m times x1 plus x2 plus c, which is 2c? Yes. So y1 plus y2 will be what? M times x1 plus x2 plus 2c. Just compare y3 with y1 plus y2. y3 is what? m times x1 plus x2 plus only c, whereas y1 plus y2 is what? M times x1 plus x2 plus 2c. Clearly y3 is not equal to what? Y1 plus y2. So here we can clearly observe that y3 is not equal to y1 plus y2. y3 not equal to y1 plus y2, that means what? We can conclude that this system whose output input relationship is what? Y equal to mx plus c, it is clearly non-linear, okay, because y3 is not equal to what? Y1 plus y2. The final conclusion is what? As you all said, the system is what? Non-linear. I hope it is understood as to how we have come to decide that the system is what? Non-linear. We just verified if superposition is what? Being satisfied or not, and we found that superposition is not being obeyed, and that means the given system, that is what? Y equal to mx plus c, it is non-linear. Can you just tell me what is the value of c for which the system would become linear? What is the value of c for which the system would become linear? You see, for this already I know that c is what? 0. You all know that c is what? 0. But see, for the system to be linear, y3 must be equal to what? Y1 plus y2. For the system to be linear, y3 must be equal to what? Y1 plus y2. Now for y3 to become equal to what? Y1 plus y2, c should become equal to what? 2c. c will be equal to 2c only for c equal to what? 0. You all agree with that? Yes. c will be equal to 2c. c will be equal to 2c only for c equal to what? 0. So here, this particular, so this system will be linear only for c equal to what? 0. This system will be linear only for c equal to 0. If c is not 0, then the system is going to be non-linear, okay? And non-linear systems do not obey superposition. That's all, okay? So that is some basic stuff about linear systems and superposition. Now let us come back to circuits. Now even our circuits are some type of systems. Even our circuits are what? Some type of systems. Just like systems can be what? Linear or non-linear. Even circuits can be what? Linear or non-linear. Just like systems can be what? Linear or non-linear. Even any circuit which is like a system can also be linear or non-linear. Now what is a linear circuit? What is a linear circuit? Linear circuit is what? Any circuit that comprises only of linear circuit elements. Linear circuits are what? Those circuits that contain only linear circuit elements. Okay, now let us understand linearity of the circuit elements. Let's understand the linearity of circuit elements. Okay. So before we actually start looking at linear circuits, let us first understand how to decide if any circuit element is what? Linear or non-linear. How to decide if any circuit element is what? Linear or non-linear. So linearity of circuit elements. You already know in this course we will restrict ourselves to what? Two terminal circuit elements. So let me draw some arbitrary two terminal element. For any two terminal element, you know, we have only two things. One is what? The voltage across the two terminals denoted by V. Another is what? The current flowing through the element from plus to minus, which is denoted by I. And for every element there will be a unique relationship between the terminal voltage and the terminal current. For every element there will be a unique relationship between the terminal voltage and the terminal current. That is what? Between V and I. Now what is a linear circuit element? Linear circuit element is what? Any element for which V is what? Proportional to I, or V and I are linearly related to each other. Any element for which V and I are linearly related to each other will be what? A linear circuit element. That's all. Okay. Any element for which V and I are linearly related to each other is a linear circuit element. Okay. Now if you go back to systems, where the system can be what? Linear or non-linear, how do you decide if any system is what? Linear or non-linear? If the output is what? Linearly proportional to the input, then we say the system is what? Linear. Now when it comes to circuit elements, you can treat one of the two variables as what? The input. Automatically the other variable becomes what? Output. So for any two-terminal element, I already said you are going to have only two variables. One is what? The voltage, another is what? The current. Now between the voltage and the current, you can choose any one of them to be what? The input. The other one becomes what? Output. For example, for some two-terminal element, if you choose the voltage as what? Input, then the current becomes what? Output. But somebody else can choose current as what? Input, then the voltage becomes what? Output. Understood, right? So in the context of linearity for circuit elements, either of the two variables, that is what? Voltage or the current, can be chosen as what? The input. The other variable becomes what? Output. Okay. And if the output and input are linearly related to each other, then the element is also what? Said to be linear. Okay. Anyway, what is our first element? It is what? A resistor. Let the first element be the very familiar element, which is the resistor. You know, all resistors obey what? Ohm's law. Ohm's law itself is what? Linearity, right? Voltage proportional to current. Straight away we can say it is what? Linear. Okay. So let this resistor have a resistance of value R. Voltage across the resistor is what? V. Current flowing through the resistor, let it be I. You know, V equal to what? I into R. Now I told you what? In the context of circuit elements, we will treat either the voltage or the current as what? The input, then the other thing becomes what? Output. Let us treat the current as what? The input, then the voltage across the resistor becomes what? Output. You can also do it the other way around, but let me choose the current to be the input, then the resulting voltage across the resistor, let it be the output. Okay. Now already we know resistor is what? Linear, but still let us go ahead and test whether resistor is what? Linear or not. How do you test if any element is what? Linear or not? You should check if that element obeys what? Superposition. Okay. So for the resistor, if the input is what? I1, then okay, one second. So for the resistor, if the input is what? I1, then what is the corresponding output? Let it be V1. What is relation between V1 and I1? In general, V equal to what? IR. So V1 will be equal to what? I1 into R. Yes or no? V1 will be equal to what? I1 times R. Now for the same resistor, you apply a different current. Let it be some I2. Let the resulting voltage be some V2. So what is V2? Will it not be I2 times R? So V2 is equal to what? I2 times R. Now again you take the same resistor. This time let the current flowing through the resistor be equal to what? I1 plus I2. and also let the resulting voltage be denoted by V3. So if you pass a current of I1 plus I2 through this resistor R, what is resulting voltage drop across R? Always it is what? Current multiplied by resistance. Will it not be I1 plus I2 times R? So V3 will be equal to what? I1 plus I2 times R. Now this I1 plus I2 times R can be written as what? I1R plus I2R. I1R is what? V1, I2R is what? V2. In other words, this V3 is indeed equal to what? V1 plus V2. Is it not? Superposition, yes or no? For I1 it is what? V1. For I2 it is what? V2. For I1 plus I2 it is what? V1 plus V2. Clearly it is what? Superposition in play. That means resistor, as we already know, it is what? Linear, because it obeys what? Superposition. Okay. So resistor it is what? Linear. Okay. Well, after resistor, let's look at, or let's find out if the voltage source is what? Linear or non-linear. Can you take a guess? What do you think? The voltage source or the independent voltage source, is it a linear element or a non-linear element? Voltage source, is it a linear element or a non-linear element? Just take a guess. What do you think? Voltage source, is it linear or non-linear? Very good. Voltage source, it is what? Non-linear. Okay. Once again, I'll just prove as to why the voltage source is going to be non-linear. Okay. So let this be the voltage source. You know, every voltage source will have a value of voltage denoted by Vs. Every current source will have a value of current denoted by Is. So for this voltage source, let the voltage be Vs. Okay. Even the voltage source is what? A two-terminal element which will have a voltage across it and also a current flowing through it. Now what is the property of voltage source? Whatever be the current, whatever be the value of I, always the value of voltage is equal to what? Vs. So irrespective of the value of I, V will always be equal to what? Vs. So we already know that V equal to what? Vs for any value of I. V, which is the voltage across the element, is always equal to what? Vs, irrespective of the current flowing through the voltage source. V equal to Vs for any value of I. Now what we will do, let us treat the current as what? Input. Let us treat, I told you what, to determine if any element is what? Linear or not, you should treat either the current or voltage as what? The input. Then the other thing becomes what? Output, and see if it obeys what? Superposition or not. So for the voltage source, let us treat the current to be the input. If you treat current to be input, then obviously the voltage across the element is going to be the output. Yes. Now for the voltage source, let us say a current of I1 is flowing through the voltage source. When a current of I1 flows through the voltage source, what is the value of voltage? It is always equal to what? Vs. Whether it is I1 or I2 or I3 or anything, V is always equal to what? Vs. So anyway, for I1 current flowing through the voltage source, let the voltage be denoted by V1, and you know V1 is going to be equal to Vs. Okay. Now for the same voltage source, if the current flowing is what? I2, let the voltage be V2, but you know again V2 will be equal to what? Vs. Again for the same voltage source, let the current be what? I1 plus I2, and let the voltage be denoted by V3, but even now V3 will be equal to what? Vs. No matter what the current, always the voltage will be equal to what? Vs. Now this V3, is it really equal to V1 plus V2? See, I1, the voltage what V1, which is equal to Vs, that is different, okay. I2 is for I2 flowing through the voltage source, the value of voltage drop is what V2. Now for I1 plus I2, if it is linear, then the voltage must be what V1 plus V2. But here what is V3? It is Vs. Is it equal to V1 plus V2? You know V1 plus V2 is what? 2 Vs. But here V3 is what? Just Vs. So clearly this is not equal to V1 plus V2. So what is the conclusion? Number one, superposition is what? Not or clearly not satisfied. Superposition not satisfied, you can say the element is what? Non-linear, okay. So voltage source or the independent voltage source, to be precise, it is what? An example for a non-linear circuit element, okay. So voltage source, it is what? Non-linear. Resistor, it is what? A linear circuit element, but the voltage source is what? It's a non-linear circuit element. In the same way, we can also show that the independent current source is also what? A non-linear circuit element. So what is it so far? Resistor, it is what? Linear. But you know the two sources, the voltage source and the current source, both are non-linear. As circuit elements, they are what? Non-linear. So if somebody will ask you, is a voltage source a linear element or not, you should definitely say it is what? Non-linear circuit element, okay. Okay, let me draw some arbitrary circuit. Just take a look at this circuit. In this circuit, there are two dependent sources. Do you all identify those two dependent sources? One is what? This thing, K1 Vx. Is it not a dependent voltage source? This one is what? It's a dependent voltage source. The other dependent source is what? This thing, K2 Vy squared. It is also another dependent source, and it is what? A dependent current source, okay. K1 Vx, it depends on what? Vx, which is the voltage across R1. Because this voltage depends on this voltage, it is what? Voltage controlled current source. So this is what? Voltage controlled voltage source. This one is what? Voltage controlled voltage source. What about this? It is a voltage controlled current source. First of all, it is what? A dependent current source. Again, it depends on what? Vy, which is the voltage across R2. So this voltage is controlling this current. So it is what? A voltage controlled current source. This one is what? Voltage controlled voltage source. This one is what? Voltage controlled current source, okay. Anyway, now the question is what? Are the two dependent sources linear or non-linear? Are both the dependent sources linear, or only one dependent source is linear? Are both the dependent sources linear, or only one dependent source is linear? How do you decide, or how do you say if any dependent source is what? Linear or not? See, for every dependent source, the value of the voltage or current, will it not depend on the controlling variable? Now linear dependent source, it will linearly depend on the controlling variable. If you look at the voltage control voltage source, its value is what? K1 Vx. K1 times Vx. Is it not proportional to Vx? Proportional to something, it is what? Linear relationship. So there is what? A linear dependent voltage controlled voltage source. But if you look at this thing, look at how its value depends on Vy, which is the controlling variable for this dependent source. It depends on Vy not directly, but it is directly proportional to what? Vy square. Had it been proportional to what? Vy power 1, then it is what? Linear dependence. Proportional to Vy square, proportional to square root Vy, all these are nonlinear dependencies. So this one is what? A dependent voltage controlled current source, but it is a nonlinear dependent source. Okay. So in this circuit, K1 Vx, because it directly depends on what? Vx power 1, it is linear. So this one, it is what? Linear. Whereas this one, whose value is what? K2 times Vy square, it is nonlinear. So understood, right? Just by looking at the dependent source, one can easily say if it is a linear dependent source or a nonlinear dependent source. K1 Vx power 1, it is what? Linear. K2 Vy square, something other than power 1, it is what? Nonlinear. Had it been K2 times Vy power 3 by 2, K2 times Vy power 3 by 2, then also it is what? Nonlinear. Or if it is K2 times square root Vy, then also it is what? Nonlinear. It should be proportional to what? Vy, or the controlling variable, power 1. Anything other than that, the dependent source will be what? Treated as nonlinear. Understood? Yes. Okay, now that we understood the meaning of any linear circuit element, how do you decide if any given circuit is what? Linear or nonlinear? I think I already told you that any circuit that comprises only of linear circuit elements will be what? A linear circuit. Okay. So let me draw a circuit which is like this. Just look at this circuit and tell me, is it a linear circuit or not? Is this circuit a linear circuit or not? Is it linear or non-linear? Is this circuit linear or non-linear? I mean, it's a very basic thing, but still you have got to be very clear about deciding whether circuits are linear or not. Okay. So is this circuit linear or not? Okay, if you actually go by what the statement that I made, what is that statement I made? Linear circuit is what? Any circuit that comprises of linear circuit elements. Just look at the different elements in the circuit. R1, is it not linear? R1 is what? Resistor. Resistor is what? Linear element. R2, another resistor, it is also what? Linear. R3, another resistor, that is also linear. Look at the dependent source, its value is what? K times Vx. When I say Vx, it is what? Vx power 1. Controlling variable power 1, it is also what? Linear. So this is also a linear dependent source. But I told you what? For any system, there will be at least one input. For any system, there will be at least one input. I think someone said something. Okay, let's get back to the discussion. I told you what? For any system, there has to be at least one input. For any system, there has to be at least one input. Now, when it comes to our circuits, which are also systems, even our circuits are what? Systems. Now, for these circuits, what are the inputs? It is the independent sources. It is the independent sources which act as what? The inputs that will drive the circuit. Any circuit is what? Driven by the various independent sources. That is what? The voltage sources and the current sources. So in the circuits, it is the independent sources that act as what? inputs. In circuits, it is the independent sources that act as what? Inputs. So what is the point here? In circuits, independent sources act as what? Inputs. Now tell me, how many inputs are driving the circuit? Number of inputs driving any circuit is simply equal to what? Number of independent sources. What is the number of independent sources? One is what? Vs, it's an independent voltage source. Another is what? Is, which is an independent current source. So this circuit is being driven by two different inputs, Vs and Is. Okay. So here, this Vs is what? Input 1. Is is what? The second input, that is what? Input 2. Understood? So the point is what? Very simple. For circuits, it is the independent sources that act as what? Inputs that will drive the circuit. So this circuit is being driven by a voltage source and a current source. Now coming to the question of what? Whether the circuit is what? Linear or not. Because when I ask if any circuit is what? Linear or not, you have to look at the circuit without inputs, because the system does not have the inputs. Inputs are what? Driving the system from outside. Inputs are driving any system from outside. So if I ask you if any system is what? Linear or not, you have to look at the circuit without the independent sources. If I ask you if any circuit is what? Linear or not, you have to look at the circuit without the independent sources. Why? Because independent sources act as what? Inputs, which are not really part of the system. Because see, if I draw the system as a block, now for this circuit there are how many inputs? Two inputs in the form of what? Vs and Is, which will be denoted by x1 and x2. So clearly the two inputs x1 and x2 are they not outside the system? So the two inputs will not decide whether the box is what? Linear or non-linear. I hope the point is clear. So if I ask you if any system is what? Linear or non-linear, you just have to look at the circuit without the inputs or without the independent sources. So if you look at the circuit without the independent sources, then what do you have in the system? You have what? R1, you have R2, you have R3, and you also have KVX. R1, R2, R3 and KVX all are what? Linear elements. That means this particular system, it is what? Linear. This particular system, it is what? Linear. I hope the point is clear. Yes or no? Dineshwaran, is it clear why the system is still linear? Because the independent sources, they act as what? Inputs, which will actually drive the system or the circuit from outside. So independent sources are not really part of the system. Independent sources are not really part of the system. They are actually present outside the system. So that is why while deciding if any circuit is what? Linear or not, you have to look at the circuit without the independent sources. Okay. So this system, it is what? Linear. This system, it is what? Linear, because apart from the independent sources, all the other elements are what? Linear elements. Since all the elements are what? Linear elements, even the system is what? A linear circuit. So this circuit, it is what? A linear circuit. Okay. Again, I'll just repeat myself. For circuits, what are inputs? For circuits, what are inputs? They are the independent sources. The independent voltage sources and the independent current sources serve as what? The inputs that will drive the circuit. In that case, what is the output? Output can be what? Any branch voltage or any branch current. So 2 points. In any circuit, independent sources will act as what? Inputs. Any branch voltage or any branch current of interest will be what? Output. Yes. So in circuits, number one, independent sources independent sources act as inputs. In circuits, it is the various independent sources that will act as what? Inputs. And then what about output? See, in any circuit, you will be interested in some branch voltage or some branch current. Whatever branch voltage and branch currents that you are interested in, they will become what? The outputs. And in most cases, you will be interested in the so-called load voltage or the load current. That will be the output. Okay. So in general, branch voltages and branch currents of interest will be the outputs. Branch voltage and branch currents of interest will be the outputs. Now, if the circuit is what? Linear. If the circuit is what? Linear. Now, when I say circuit is what? Linear, it means we have a linear system. It means what? We have a linear system. What is the property of any linear system? Every output will be a linear combination of the various inputs. Now, in the context of circuits, if you apply the same point or same definition, what is output? Any branch voltage or any branch current of interest, that will be the output. What are the inputs? The various independent sources are what? Inputs. That means you take a linear circuit. If you have a linear circuit, every branch voltage and every branch current, that is what? Every output will be a linear combination of the various inputs. In this case, or in the case of circuits, the inputs are what? Independent sources. So I can say every branch voltage and every branch current will be some linear combination of the various independent sources. Every branch voltage and every branch current will be what? Some linear combination of the various independent sources. I am just manipulating the standard statement for a linear system. What is the statement for a linear system? Every output will be what? Some linear combination of the various inputs. Now, when it comes to circuits, outputs are what? Branch voltage and branch currents of interest. So I can say every branch voltage and every branch current will be some linear combination of the various independent sources. Okay, this is, even though it's a simple point, but it has profound implication. Okay, what is it? Every branch voltage and every branch current will be some linear combination of the various inputs which are the independent sources. Okay, every branch voltage and every current will be some linear combination of the various independent sources. As simple as that. Okay, that means what? If you have a linear circuit driven by multiple independent sources, if you have a linear circuit driven by multiple independent sources, I told you what? Independent sources are like inputs. When I say multiple independent sources, does it not mean multiple inputs? Yes or no? Linear circuit, listen carefully, linear circuit driven by multiple independent sources. Linear circuit is like linear system. Multiple independent sources, it is like multiple inputs. Okay, so what is it? First we have a linear circuit being driven by multiple independent sources. Linear circuit driven by multiple independent sources. It is actually same as what? It is same as a linear system. It is same as what? A linear system being driven by multiple inputs. Do you all agree with that statement? Linear circuit is same as what? Linear system, because every circuit is what? System. Every circuit is what? It's a system. So linear circuit is what? Same as linear system. And independent sources are nothing but inputs. So linear circuit driven by multiple independent sources is same as what? Having a linear system being driven by multiple inputs. Okay, driven by multiple inputs. I told you what? If you have a linear system driven by multiple inputs, we can apply that superposition. Okay, let me first illustrate superposition applied to a linear system driven by multiple inputs. So let us say we have a system for which there are three inputs. We have a linear system for which there are three different inputs labeled x1, x2 and x3, and just to keep it simple, let there be only one output. So we have what? A linear system. We have a linear system having three different inputs, x1, x2 and x3, but there is only one output, let it be y. Now because it is what? A linear system, you know, output will be what? A linear combination of the three inputs. It will be something like k1 x1 plus k2 x2 plus k3 x3. Yes, an output will be of the form k1 x1 plus k2 x2 plus k3 x3. Now for this linear system driven by three inputs x1, x2 and x3, we can perform superposition. Now what is that superposition? It is like conducting three different experiments, where in each experiment we only keep one input active, we make the other input 0, we find the corresponding output in that experiment, we repeat it for the other two inputs. In the end, to get the net output, when all the three inputs are acting at the same time, we just have to add the various outputs in the three separate experiments. Okay, so it is like this. Case 1, it is what? Like experiment 1. I told you what? In each experiment we will keep only one input active. So in the first case, let x1 be present. Let us not apply x2 and x3. Not applying x2 and x3 is same as what? Making x2 and x3 0. So in the first case, x1 is what? Active. In the first case, let x1 be active and let us deactivate the other two inputs, that is x2 and x3. So x2 and x3, we just make them 0. Okay. Now what is it like? Again we have the same system. x1 is what? Present, but you know x2 and x3 both are being made 0. Let the output in the first case be denoted by y1. Let the output in the first case be denoted by y1. So what is y1 going to be? Always use the general expression k1 x1 plus k2 x2 plus k3 x3, and here in the first experiment x2 and x3 have been made 0. So when you make x2 and x3 0, even k2 x2 and k3 x3 will become 0. Y will simply be equal to what? K1 x1. So the output in the first experiment is simply equal to what? K1 times x1. Okay. Now for the same system, let's perform another experiment. Let us perform another experiment wherein we will keep x2 active, because in the first experiment x1 it was kept active. In the second experiment, let us keep x2 active and let's make the other two inputs 0. If you keep x2 active, what are the other two inputs, x1 and x3? x1, x3, let's make it 0. Now what is the system going to look like? x1 0, x2 is what, active, x3 is also made 0. Let the output in the second case or in the second experiment be denoted by y2. Again, use the same general expression. This time x1 and x3 both are 0, which means k1 x1 and k3 x3 are also going to be 0. Y is equal to what? K2 times x2, which means y2 will be what? K2 times x2. y2 will be what? K2 times x2. This is the output if only x2 is present. If only the input x2 is present, then the corresponding output is what? K2 times x2. And what is k1 x1? It is the output if only the first input is present. That is, if only x1 is present, the output is what? K1 x1. If only x2 is present, the output is what? K2 x2. I hope it is clear. Okay. We need to perform one more experiment, right? Because in the first experiment only x1 has been kept active. In the second experiment only x2 has been kept active. Now in the third experiment, let us keep x3 active. Okay. So once again, okay. So this is what? Case 3. This time x3 is what? Active. This time x3 is what? Active. And because x3 is what? Active, you have to make the other two inputs, that is x1 and x2 0. Let's make x1, x2 both 0. So this time what is the system going to look like? The first two inputs are made 0, but the third input will remain active, that is what? X3. Let the output in this case be some y3. Again, the general expression for the output is what? K1 x1 plus K2 x2 plus K3 x3. In the third experiment, we are making both x1 and x2 0. If you are making x1 and x2 0, then you know K1 x1 plus K2 x2 is also going to be 0. Only this K3 x3 term will remain. Then y3 will be equal to what? K3 times x3. y3 will be equal to what? K3 times x3. So what is this K3 x3? It is the output if only x3 is present. It is the output if only x3 is present. Okay. But in the actual system, or for the actual system, all three inputs are applied at the same time. But what did we actually find? We found the output in every individual case where only one input it was active. We found the output in every individual case where only one input was active. If only x1 is present, output is what? y1. If only x2 is present, output is what? y2. If only x3 is present, then the corresponding output is what? y3. Now because our system is what? Linear, if all three inputs are applied at the same time, you just have to add the individual outputs. Yes or no? So here, for the same system, if all three inputs are applied at the same time, that is what? x1, x2, x3, all three are present. You see this case where all three are present, is it not the combination of the three experiments? Yes or no? If you add the three experiments on the input side, you will get x1, x2 and x3. Because this case is being obtained by adding the three individual experiments, even the output must be what? Sum of the three outputs obtained in the three experiments, that is what? Case 1, case 2 and case 3. So here y will be equal to what? y1 plus y2 plus y3. So this is just an illustration of superposition applied to what? A linear circuit, not linear circuit, sorry, linear system driven by multiple inputs. So what is the point I am trying to convey? If you have a linear system driven by multiple inputs, you can consider only one input at a time. You find the corresponding output. You repeat it for all the inputs, where for every input you keep only that input active. You make all the other inputs 0, find the corresponding output and so on. Now in the actual case where all the inputs are present at the same time, the actual output will be what? Sum of all the individual outputs. Like in this case, the output when x1, x2 and x3 all three are present at the same time is equal to what? y1 plus y2 plus y3. I hope it is clear. This is the application of superposition. So in what scenario can you apply superposition? When you have a linear system driven by multiple inputs. And in the context of circuits, it is what? When you have a linear circuit driven by multiple independent sources. When you have a linear circuit driven by multiple independent sources. Remember, independent sources are nothing but inputs. So when you have a linear circuit driven by multiple independent sources, again we can use what? Superposition. Okay. That means, let us say okay, there is some arbitrary circuit. It can be any circuit. Let this be Vs1, let this be Vs2, R1, R2, R3, R4, and let this be Is. And in this circuit, let the output or the variable of interest, let it be the voltage across R3. So what is the variable of interest to us? It is the voltage across R3. Voltage across R3 is what? The variable of interest, which means voltage across R3 is what? Like the output voltage. So question number 1, is this circuit linear or not? Is this circuit linear or not? I told you what? To decide if any circuit is what? Linear or not, you have to look at the circuit without the independent sources. How many independent sources are there in this circuit? 3 independent sources. One is what? Vs1, another is what? Vs2, another voltage source, and then we have this Is. So are we not having 3 independent sources? How many inputs are driving the circuit? 3 inputs are driving this circuit. Vs1, Vs2 and Is. So in this circuit, there are what? 3 inputs. In this circuit, there are 3 inputs. What are the 3 inputs? Vs1, Vs2 and Is. Okay. So if you look at the circuit without the independent sources or the inputs, then we only have what? 4 resistors, right? Without the independent sources in the circuit, there are only 4 resistors, R1, R2, R3 and R4. And you know, resistor, it's a linear circuit element, because all 4 are what? Linear circuit elements. The given circuit, it is what? A linear circuit. So are we not having a linear circuit driven by how many inputs? 3 inputs. Linear circuit driven by 3 inputs is same as what? Linear system being driven by 3 inputs. Just now I told you what? When you have a linear circuit or a linear system driven by 3 inputs, you can apply what? Superposition. In fact, any linear circuit driven by 2 or more inputs, you can apply what? Superposition. Okay. So here also what you can do, keep only Vs1 active. Conduct 3 separate experiments. In the first experiment, I'm not going to write anything here. I'll just explain in words. Okay. So because there are 3 inputs, you can conduct 3 separate experiments. Let us say in the first experiment, you keep only Vs1 active. You keep only Vs1 active. You make the other 2 independent sources 0. That is what? Vs2, you make it 0. Is also you make it 0. You find the resulting voltage across R3. So it is like this. So due to Vs1 alone, meaning if only Vs1 is present and if these 2 are made 0, you will get some voltage across R3. Let that voltage be denoted by V01. Okay. Now conduct a second experiment where you keep only Vs2 active. Where you keep only Vs2 active. when I say keep only VS2 active, you have to make the other two inputs or the other two independent sources 0. So keep only VS2 active, that means make this VS1 and IS 0. Then also you'll get some voltage across R3. That is what the output only due to VS2. If only VS2 is present, you will get some voltage across R3. Let it be V02. So what is V01? It is the voltage across R3 if only VS1 is present. What is V02? It is the voltage across R3, or it is the output if only VS2 is what present. Now you have to conduct a third experiment where IS will be active and the other two independent sources you will make them 0. So in the third case, IS will be present or active, and you have to make VS1 and VS2 both 0. Again, due to IS, there will be some voltage across R3. That is what the output only due to IS. Output only due to IS, let it be denoted by V03. Now in the actual circuit, all three inputs are acting simultaneously. That is what, at the same time. So when all three inputs are applied or acting at the same time, then the net output will be what, sum of the three individual outputs. Yes or no? So here V0 will be equal to what? V01 plus V02 plus V03. That's all. This is superposition applied to this linear circuit driven by three inputs in the form of what? VS1, VS2 and IS. You understood? So conduct separate experiments where in every experiment only one source is what kept active and all the other independent sources are made 0. Remember, dependent sources, they are part of the system. Dependent sources, they are what? Part of the system. They do not act as what? Inputs. It is only the independent sources that will act as what? Inputs. And here in this explanation, I made a statement. Let us say in the first experiment, only VS1 is what kept active. When I say only VS1 is what kept active, it is understood that you have to make all the other independent sources 0. In this case, if only VS1 is what kept active, you should make this voltage source VS2 0. You should also make this current source IS 0. Now what do you mean by making independent sources 0? What do you mean by making independent sources 0? See, every independent source, will it not have a value? Independent voltage source will have what? A value of voltage. Independent current source will have what? A value of current. Yes or no? Independent voltage source will have a value of voltage. Independent current source will have what? A value of current. So when I say make an independent voltage source 0, indirectly I am saying that make the value of the voltage of that independent voltage source 0. And when I say make an independent current source 0, make the value of the current of that independent current source 0. That is the meaning of making any independent source 0. So make voltage source 0, it means what? Make the value of voltage 0. Make current source 0, it means what? Make the value of the current 0. Okay, so before I draw the actual thing for zeroing any independent source, let us discuss a little bit about open circuit and short circuit. Already we know resistor. All resistors obey what? Ohm's law. All resistors obey what? Ohm's law. So let it be a resistor of value R, across which the voltage drop is what? V, through which the current is what? I. Now the open circuit and the short circuit are nothing but the special cases of any, or the extreme cases of any resistor. Yes. What is it? Open circuit and short circuit are nothing but extreme cases of a simple resistor. Now what are those extreme cases? Value of resistance, that is what? R. At one extreme it can be what? 0. At the other extreme it can be so large that it will tend to what? Infinity. That's all. So for this resistor, the two extremes are what? R equal to 0 and R tending to infinity. Yes or no? For a resistor, the value of resistance can be as low as 0 or it can be as high as infinity. You understood? So when R equal to 0, that is what is called a short circuit, and when the value of resistance tends to what? Infinity. That is what is called open circuit. Okay. Now again, anyway, what is that Ohm's law? V equal to what? I into R. The other way to express Ohm's law is what? I equal to 1 by R times V. V equal to what? IR, or I equal to what? 1 by R into V. Now first let's talk about short circuit. When do you get a short circuit? When you have a resistor whose resistance is what? 0. When you have a resistor whose resistance is what? 0, it is a short circuit. Yes. See, when R is 0, whatever be the current, yes or no, when R is 0, I multiplied with R, will it not be 0? Yes or no? When R is 0, I multiplied with R is like multiplying I with 0. Anything multiplied with 0 is what? 0. So when R is 0, IR is also what? 0. So for a short circuit, IR equal to 0, that means what? The voltage drop is always 0. IR equal to 0, voltage drop is what? Always 0. So for a short circuit, the voltage drop is what? Always 0. And how do you represent a short circuit? Is it not like this? Just replace the resistor with a short circuit. Short circuit is what? It's like a piece of wire having 0 resistance. Short circuit is what? It's a piece of wire having 0 resistance. Wire with 0 resistance. Is it not ideal conductor? Yes or no? Wire with 0 resistance is nothing but an ideal conductor. Okay. So what is a short circuit? It is just a simple piece of wire having no resistance at all, which is like an ideal conductor. And what is 0 for a short circuit? Number one, resistance is what? 0. And because resistance is what? 0, voltage drop is also what? 0. Always for a short circuit, voltage drop is what? 0. What about the current? Any current can flow, because short circuit is what? It's a simple piece of wire, and through a piece of wire any amount of current can flow. So for a short circuit, what is always 0? Voltage drop is what? Always 0, but any amount of current can flow. Okay. So for this short circuit, I is what? Current flowing in the short circuit. That is what? That piece of wire. And this V, it can be anything. I hope this point is clear. So always for a short circuit, resistance is what? 0, voltage drop is what? 0, but any amount of current can flow through what? A short circuit. And how much current will flow through the short circuit? It depends on the external circuit, because outside the short circuit you will have some sources and elements connected, right? They will decide how much current will flow through the short circuit and so on. So for a short circuit, voltage drop is what? 0 always, and current can be anything. So any amount of current can flow through the short circuit. Okay. Now let us go to the other extreme. One extreme is what? The value of resistance being 0. The other extreme is what? The other extreme is what? R tending to infinity. You say if R tends to infinity, what about 1 by R? If R tends to infinity, 1 by R, will it not tend to 0? Then the current, will it not be equal to 1 by R, which is 0 multiplied with voltage? 0 multiplied with anything, again it is what? 0. So for an open circuit, resistance is what? Infinite. So the current will be what? 0. Yes. So open circuit, current is what? 0. Open circuit, it is the current that is always going to be 0. In fact, how do you represent an open circuit? Just remove the resistor. Just short circuit case, we replace the resistor with a piece of wire. That is what? Short circuit. Open circuit means what? Just take out the resistor. You have an open circuit. In fact, if you look at the open circuit, clearly there is no path for current to flow. For current to flow, there has to be a continuous path. But for an open circuit, there is no path for current to flow. That way also we can say current is what? 0. Or the other way to put it is what? Because the resistance is what? Infinite. It offers infinite resistance, so no current will flow. That is also one way of arriving at the fact that for an open circuit, current is what? 0. What about voltage? Voltage can be anything. Across an open circuit, meaning across these two terminals, you can have any amount of voltage drop. Okay, so across this across these two terminals, if the voltage drop is what V, now this V, it can be anything. So just to summarize, short circuit resistance is what? 0, voltage drop is what? 0, always. Current can be anything. Open circuit resistance is what? Infinite. Current is what? 0, but voltage drop across the open circuit can be anything. You understood? Short circuit, voltage is always 0. Open circuit, current is always 0. Short circuit, any amount of current can flow in that short circuit, which is nothing but a simple piece of wire. Open circuit, any amount of voltage drop can be present across these two terminals. You understood? This is about open circuit and short circuit. Okay. Now, if I say make a voltage source 0. When I say make a voltage source 0, when you make a voltage source, it is the value of voltage that becomes what? 0. Value of voltage is what? Vs, and that Vs you are going to make it 0. So when you make a voltage source 0, it is the voltage drop that becomes 0. Now for which element the voltage drop is always 0? Is it not for a short circuit? It is only for a short circuit that the voltage drop is what? Always 0. So in other words, let us say this is what? The voltage source of value Vs, and when you make this 0, when you make this voltage source 0, then the value of voltage becomes what? 0. It is only for a short circuit that the value of voltage is what? Always 0. So this voltage source, when you make it 0, it becomes what? A short circuit. When you make it 0, it becomes what? A short circuit. Okay. So voltage source. So even though you already might be knowing this point, but still you should be clear about these basic things. Okay. So when you make a voltage source 0, it is the value of voltage that becomes 0, and it is only for a short circuit that the voltage drop is what? Always 0. What is the other source we got? We also have a current source. If I make a statement that make a current source 0, make current source 0. I told you what, when you make any source, the value of that source, it becomes what? 0. So when it comes to current source, it is the value of the current that becomes what? 0. For a current source, the value of the current is what? Denoted by Is, and that Is, it becomes what? 0. So current source, when you make it 0, always the current will be 0. Now what is that element for which always the current is 0? Is it not an open circuit? That means if you have a current source, and again if you make it 0, if you have a current source and if you make it 0, the value of the current, it becomes 0. So it becomes what? An open circuit. Okay. Because if you are using what? Superposition, you will conduct what? Number of experiments, where in each experiment you will keep one source active, you will make the rest of the sources 0. When you say rest of the sources are made 0, voltage source and current source both should become 0. Yes. And when you make a voltage source 0, it becomes what? A short circuit. And when you make a current source 0, it becomes what? An open circuit. So this is pretty much the background that is required to be able to use what? Superposition. So a couple of points to summarize the discussion. First of all, circuits can be what? Linear or non-linear. How do you decide if any circuit is what? Linear or non-linear? You have to look at the circuit without the independent sources. Why? Because independent sources act as what? Inputs that will drive the circuit. So if you look at the circuit without the independent sources, and if the circuit contains only linear circuit elements, then the circuit is said to be what? Linear. And if you have a linear circuit driven by multiple independent sources, then we can always use this superposition, where you find the output when only one input is what acting and so on. You do number of experiments where in each experiment only one input is what active and so on, and then in the end you just add up all the results or all the outputs to get the net output when all the inputs are present at the same time. I hope this is clear. Okay, now let us start looking at a few circuit examples wherein we will try to perform what superposition. Okay, so we will take up an extremely simple circuit to illustrate this superposition. Okay, okay, first things first, is this circuit linear or not? Is this circuit linear or not? It is linear because first of all there are two independent sources, right? One is the 3 volt voltage source, another is what, the 2 ampere current source. So these two are what, the two independent sources which will act as what, the inputs. So if you look at the circuit apart from the inputs, we only have two resistors, 6 ohm and the 9 ohm resistors, both of which are linear. So what are we having here? We are having a linear circuit being driven by two inputs. We are having what? A linear circuit driven by two inputs. Now the variable of interest is what? The current flowing through the 9 ohm resistor denoted by I, and the question is what? To find I using the method of superposition. Because it's a linear circuit driven by two inputs, we can definitely apply superposition. Again, so just because it's a linear circuit driven by two inputs does not mean that you should only go by superposition. Even without using superposition also, we can just like that get the value of I. But here the goal is what? To get used to the approach, the superposition way of doing things. Okay, so what is that superposition? How many experiments have to be conducted for this circuit? Because there are two inputs, you have to conduct two separate experiments. In the first experiment, you will keep only the 3 volt source active, find the current through 9 ohms, let it be I1. In the second experiment, you will keep only the 2 ampere current source active, again you will find the current through 9 ohms, let it be I2. Now the net current flowing through the 9 ohm resistor when both the sources will be present will be how much? I1 plus I2, as simple as that. Okay, anyway, first is what? Case 1. In the case 1 or in the first experiment, 3 volt source is what? Active, and the 2 ampere, 2 ampere source, let's make it 0. 2 ampere source, let's make it 0. Let us only keep the 3 volt source active. Okay, I already told you, if you are making a voltage source 0, it becomes a short circuit, and if you make a current source 0, it becomes what? An open circuit. Okay, so in the first case, 3 volt source will remain active. That means what? 3 volt source will remain as it is. 2 ampere current source becomes 0. Just replace the 2 ampere source with an open circuit. How will the circuit be? See, I hope all of you agree with the circuit diagram for the first case, where only the 3 volt source is what present and the 2 ampere current source has been made 0. Current source, when you make it 0, it becomes what? An open circuit. Let me assign values to the two resistors, 6 ohms and 9 ohms. Let the current through the 9 ohm resistor in the first case be some I1. In fact, if you look at this circuit, are we not having 6 ohm and 9 ohm resistors in series? Because when the current source becomes 0, what is the current in this branch? Open circuit current is what? 0. Now, whatever current flows through what? 6 ohms, the same current will flow through what? 9 ohms. Yes or no? Because this current is 0. Current through 6 will also flow through what? 9. 6 and 9 both are in series. 6 and 9 both are in series across what? Voltage source. It's all about finding the current. Current will be equal to what? Voltage divided by net resistance. 6 and 9 in series. Net resistance is what? 6 plus 9, which is 15 ohms. So the current flowing in the circuit will be what? 3 volts divided by 15 ohms. Okay. So what is I1? What is I1 going to be? 3 volts divided by 15 ohms. 3 by 15 is what? 1 by 5, which is 0.2 amperes. So what is this 0.2 amperes? It is the current that will flow through the 9 ohm resistor when only the 3 volt source is what? Present. Let us also find the power dissipated by the 9 ohm resistor. Let's also find the power dissipated by the 9 ohm resistor when only the 3 volt source is present. I'll say it again. We are trying to find what? Power dissipated by the 9 ohm resistor when only the 3 volt source is present. When only 3 volt source is what? Present. Current through 9 ohms is what? 0.2 amperes. If you know the current through any resistor, power dissipated by that resistor is what? I square into R. So P1, it is what? I1 squared into 9. I1 is what? 0.2. I1 square is what? 0.2 square, which is 0.04 into 9. 0.04 into 9 is what? 0.36. So what is this 0.36 watts? It is the power dissipated by the 9 ohm resistor or power supplied to the 9 ohm resistor when only the 3 volt source is present. In the same way, let us do the calculation for the second experiment. In the second experiment, it is the current source that will remain active and the voltage source, you should make it 0. Okay. Look at this. Case 2, the 3 volt source, we have to make it 0 and the 2 ampere current source is going to remain active. Once again, how will the circuit be? 2 ampere current source active, let the 2 ampere current source remain as it is. 3 volt source becomes 0 or you should make it 0. When you make a voltage source 0, it becomes what? A short circuit. Just replace the 3 volt source with a short circuit. Rest of the circuit will remain as it is. Let the current through the 9 ohm resistor in the second experiment be denoted by I2. So I1 is what? Current only due to the 3 volt source. I2 is what? Current only due to the 2 ampere current source. Okay. Anyway, now if you look at the circuit, carefully, you will find that the 6 ohm and the 9 ohm resistors both are in parallel. Yes or no? Because see, this entire thing is what? One node. And this entire thing is what? Another node. So in this circuit, we got only 2 nodes. Okay. There is one node. This entire thing is what? Another node. Look at 6 ohms between these 2 nodes. Look at 9 ohms also between these 2 nodes. Look at 2 amperes also between these 2 nodes. Is it not a single node pair circuit? This one is what? Single loop circuit. Yes or no? 6 and 9 both are in series across a voltage source. It is what? A single loop circuit. All elements are in series. This one is what? A single node pair circuit because all elements are present between the same 2 nodes. In this circuit, all elements are going to be in parallel. Yes, here all are in series. Here all are in parallel. Yes. What happens when you have two resistors in parallel across a current source? What happens if you have two resistors in parallel across a current source? What will take place? Current division will take place. Yes or no? This 2 amps will get divided between what? 9 and 6. Part of this 2 amps will flow through what? 9. The remaining current will flow through what? 6. Yes or no? Part of this 2 amps will flow through what? 9. The remaining current will flow through what? 6. Now we are interested in what? The current flowing through 9 ohms, which is what? I2. So what is I2? Current through 9 ohms. In case of current division for two resistors, if you recall, what is the conclusion that we had? In case of current division for two resistors, current through one resistor will be directly proportional to what? The other resistance. So current through 9 will be proportional to what? 6. So I2 will be equal to what? First you write the current that is getting divided. What current is getting divided? 2 amps is what getting divided between 6 and 9 ohm resistors. So first you write 2. I2 is what? Current through 9, which will be proportional to what? 6 multiplied with 6, then divided by the sum of the two resistors, which is again 6 plus 9 or 15. So what is the value of I2? 2 times 6 is what? 12. 12 divided by 15 is what? 4 by 5, which is 0.8. Which is 0.8. So what is the current through the 9 ohm resistor only due to the 2 ampere current source? What is the current through the 9 ohm resistor only due to the 2 ampere current source? It is 0.8 amps. Okay. Let us also find the power dissipated by the resistor. Let us also find the power dissipated by the 9 ohm resistor when only the 2 ampere current source is present. When only the 2 ampere current source is present, the current through 9 ohms is what? 0.8 amps. So the power dissipated by the 9 ohm resistor will be what? I2 squared into the resistance, which is what? 9. Okay. So P2 will be what? I2 squared into 9. 0.8 squared is what? 0.64. 0.64 into 9. What is 0.64 into 9? Is it not this much? 5.76 watts. So what is 0.36 watts? It is the power dissipated by the 9 ohm resistor when only the 3 volt source is active or present. And what is this 5.76 watts? It is the power dissipated by the same 9 ohm resistor when only the 2 ampere current source is what? Present. But you should find the net current flowing through the 9 ohm resistor when both the sources are present. Now what is that superposition? When both the sources are present at the same time, then the net output will be what? Sum of the individual outputs. So here the value of I will be equal to what? I1 plus I2. Yes or no? Net current through the 9 ohm resistor will be equal to what? I1 plus I2. What is the value of I1? What is the value of I1? 0.2. What is the value of I2? It is 0.8. What is I1 plus I2? 0.2 plus 0.8, which is 1 ampere. So when both the sources are present at the same time, then the current through the 9 ohm resistor will be how much? It will be exactly 1 ampere. 0.2 plus 0.8, which is 1. Now let us find the actual power dissipated by the 9 ohm resistor in the circuit when both the sources are present, and I will denote that by P 9 ohms. So P 9 ohms is what? The actual power dissipated by the 9 ohm resistor. Will it not be I square into R? Will it not be 1 square into 9, which is 9 watts? That is the actual power dissipated by the 9 ohm resistor when both the sources are present at the same time. How much is that? 9 watts. But what is the power dissipated by the 9 ohm resistor when only 3 volt source is present? 0.36. What is the power dissipated by the 9 ohm resistor when only the 2 ampere current source is present? 5.76. Now this P 9 ohms, which is the actual power dissipated by the 9 ohm resistor, is it equal to P1 plus P2 or not equal to P1 plus P2? What is P1? 0.36. What is P2? 5.76. If you add P1 and P2, then P1 plus P2 will be what? 0.36 plus 5.76, which is 6.12. Yes, P1 plus P2, it is what? 6.12 watts. Clearly, it is not equal to what? The actual power dissipated by the 9 ohm resistor, which is 9 watts. So here the point is what? The actual power dissipated by the 9 ohm resistor, it is not really equal to what? P1 plus P2. That means for doing power calculations, for doing what? Power calculations, do not use superposition. To find the currents and voltages across any branch or for any branch, you can use what? Superposition. So using superposition, you find the net current or the net voltage, then you find the actual or the exact value, the power absorbed or power dissipated by that branch and so on. Okay, but you should not use superposition while finding what? The power dissipated or power absorbed by any branch. Like in this case, the actual power dissipated by the 9 ohm resistor, it is not really equal to what? P1 plus P2. So do not use superposition for power calculations. Use it to find the net voltage or net current across any branch. You understood? I mean, it should be logical, because how does the power depend on the current or voltage? Look at the expression for the power. It is what? I square R. Power depends on square of current. Or how does it depend on voltage? V square by R. Again, power depends on what? Square of voltage. Square dependence is what? Linear or non-linear? Square dependency, it is what? Non-linear. That is why we should not use superposition while doing what? Power calculations. Always find the net voltage or the net current using superposition. Then you find the value of the power absorbed by that branch and so on. Okay. So even though it's a simple point, you should not be careless and get the wrong answer by using what? Superposition in the context of power calculations. Okay. Do not use superposition for power calculations. Use it only to find the net voltage or the net current in any branch, and then do the whatever power calculation that you want to do. Okay, and then find the power absorbed or supplied by that branch. I hope this point is clear. Okay. Yes, all of you, please solve this question. Again, circuit is what? Linear. How many independent sources are there in this circuit? Two independent sources. One is what? The 10 volt voltage source. Another is what? The 3 ampere current source. So these two independent sources will act as what? The inputs driving the circuit. Apart from the two independent sources, we have what? Two resistors, 2 ohm and 1 ohm, both of which are linear. And then we also have a dependent voltage source whose value is what? 2ix. Is it not ix power 1? Yes or no? 2ix. It is what? Ix power 1. Controlling variable power 1. Controlling variable power 1. It is what? Linear. Resistor, linear dependent source. Everything is what? Linear. So are we not having a linear circuit driven by two inputs? What are the two inputs? 10 volt source and the 3 ampere current source. And the output quantity of interest is what? The current through the 2 ohm resistor, that is what? Ix. So find the value of Ix using superposition. Please do it fast. Find the value of Ix using superposition. Dineshwaran says it is 1 amp. Sainath 1.4. Sai Prasanna 3.3. Okay. Let us find the value of Ix. You see, already I told you that there are two inputs. So we have to perform two separate experiments, where in each experiment only one source will be kept active. So in the first case, let us find Ix when only 10 volt source is present. In the second case, let us find the value of Ix when only the 3 ampere current source is present. Okay. So this is case 1. Case 1, 10 volt source is active, whereas the 3 ampere source, let's make it 0. 10 volt source active, that means it will remain as it is. 3 ampere current source 0, it becomes open. Okay, look at this. 10 volts, 2 ohms, current source 0, I just make it open. And then we have the 1 ohm resistor. Then this is 2 Ix. You see, in the first case, let us denote Ix by Ix prime. Let us denote Ix by Ix prime. Okay. Now if this is Ix prime, even this will be Ix prime, 2 Ix prime, yes or no? Now let us find the value of Ix prime. Now, is it not a single loop circuit? Because this is no open circuit, no current will flow through open circuit. Clearly 2 ohm and 1 ohm both will be in series, because no current will flow in the open circuit. Whatever current flows through 2 ohm, the same current will also flow through the 1 ohm resistor. Now all elements are in series around a single loop. Now this Ix prime, is it not like the loop current? It is like the loop current. Let us apply KVL around this loop starting from this point. Okay. Tell me, what is KVL going to be starting from this point? So starting from this point, if you go in the clockwise direction, first we encounter minus. So minus 10 plus 2 Ix prime plus 1 Ix prime plus again 2 Ix prime equal to 0. That's all. 2 plus 1 plus 2 is 5 Ix prime equal to 10. So what is Ix prime? It is 2 amps. So what is this 2 amps? It is the value of, okay, let me write 2 properly. So what is this 2 amps? It is the value of Ix when only the 10 volt source is present. Now you have to conduct the second experiment where only the 3 ampere current source will be present. Okay, look at this. Case 2, 10 volt source will become 0, whereas the 3 ampere current source, it will remain active. 10 volt source, it will become 0, and the 3 ampere current source, it will remain active. 10 volt source, when you make it 0, voltage source 0, it becomes a short circuit. Yes. So I'll just replace the voltage source with a short circuit. Rest of the circuit I'll write as it is. 2 ohms. This is 3 amps. This is 1 ohm. Then we have the dependent source, 2 Ix. Once again, see, this time let us call the Ix in the second case as Ix double prime. let us call it as Ix double prime. Ix prime is what in the first case, Ix double prime is what in the second case. Okay, do not change the direction, let it flow in the same direction, that is what towards the right. So this is what Ix double prime, even this will be what 2Ix double prime. Now in this circuit we have to do something and find the value of what Ix double prime. Okay, again you can do it in multiple ways, but the best way is what, first you apply KCL at this point. See what is this current, because this branch contains what, a current source, current flowing upwards, so this current will be what, 3 amps. Now can you tell me what is this current? See, if you look at this node, Ix double prime is what entering, 3 is also entering. I'll say it again, at this point Ix double prime is what entering, 3 is also entering, and this current is what leaving. So this leaving current must be equal to what, sum of the two remaining entering currents, which is 3 plus Ix double prime, 3 plus Ix double prime, that's all. Now what we will do, let us apply KVL around this loop. Let us apply KVL around the outer perimeter of the circuit. You can start from any point. Let us start from this point and apply KVL. So if you start from this point and if you go like this, is it not the 2 ohm element, 2 ohm resistor, that is the first element. Again current through 2 ohms is what, Ix double prime. So won't you get 2 times Ix double prime? Yes. Well, after the 2 ohm resistor we have the 1 ohm resistor through which the current is what, 3 plus Ix double prime. Again current flowing from left to right, plus minus, you are encountering what, plus first. So plus 1 times the current, which is 3 plus Ix double prime. Then again we are encountering what, plus first, write down plus 2 Ix double prime. Then you are back to the starting point. KVL means what, sum of the voltage around the loop is what, 0, that's all. Now 2 Ix double prime plus Ix double prime plus again 2 Ix double prime is what, 5 Ix double prime equal to what, minus 3. So what is Ix double prime? Minus 3 by 5, which is minus 0.6. So what is Ix double prime? It is minus 0.6 amps. So what is this minus 0.6 amps? It is the current flowing through the 2 ohm resistor when only the current source is what, present. When only voltage source is present, the current through 2 ohms is what, 2 amps. Now superposition, it means what, in the end you have to add the two results to get the net output. In this case the net current through the 2 ohms will be what, Ix prime plus Ix double prime, that's all. So here Ix will be equal to what, Ix prime plus Ix double prime. Ix prime is what, 2, Ix double prime is what, minus 0.6. So 2 minus 0.6, which is 1.4 amps. That's all. This is how we can get the value of Ix by way of superposition. I hope the approach is clear. Always be systematic. Okay, write the two cases properly, find the output in each case. In the end you just add the individual outputs. I hope this is clear. Okay. So there is one more small point I would like to add to our discussion on superposition. Any doubt? Okay, cool, no problem. So what is that point? You say, okay. let's say we have a linear system. What is it? We have a linear system with two inputs x1 and x2, and with only one output, let it be some y. Okay. Now for this system, okay. Let's say there is only one input. And let that single input be some x, and let the corresponding output be y. Because I am saying it is what a linear system, obviously y will be equal to what? Kx. Y will be equal to what? Kx. Okay. Now for this linear system, first let us apply an input x1 and let the corresponding output be some y1. And for the same system, if you apply a different input, say x2, let the corresponding output be some y2. Okay. Then according to superposition, what is that superposition thing? For the same circuit or for the same system, if you apply an input which is x1 plus x2, then the output will be what? Y1 plus y2, because the system is what? Said to be linear. If you apply x1 plus x2, then even the output will be what? Sum of the two individual outputs y1 plus y2. Now you can apply any linear combination of these two inputs, that is what? X1 and x2. You can apply any linear combination of x1 and x2, not necessarily x1 plus x2. In fact, you can apply some k1 x1 plus k2 x2. Okay, you can apply what? K1 x1 plus k2 x2. So what is happening here? The first input x1 has been scaled by a factor k1, so that it becomes what? K1 x1. The second input x2 also has been scaled by some factor, which is k2. Then the scaled inputs are being added. Okay, k1 x1 plus k2 x2 is applied as the input to the same linear system. So when the inputs are scaled, because it's a linear system, even the outputs will get scaled by same factor. That means for k1 x1, the output will be what? K1 y1. For k2 x2, the output will be what? K2 y2. So obviously when you apply what? K1 x1 plus k2 x2, even the outputs will get scaled by the same factor and then get added. Okay, so what is the output in this case? So same scaling and so on. K1 y1 plus k2 y2. This again the outcome of the system being linear. Okay, so x1 output is what? Y1. x2 output is what? Y2. So you apply any linear combination of x1 and x2, even the output will be what? The same linear combination. That is what? K1 x1 plus k2 x2 is what? The input. Then the output will also be what? K1 y1 plus k2 y2. I hope this simple point is clear. Okay. Okay. Take a look at this question. Look at this box. Inside the box I wrote resistors only. That means what? Inside the box we have only resistors connected in some arbitrary fashion. Okay. And outside the box, which contains what? Resistors. Outside the box we have what? A current source denoted by IA, independent current source. Remember, independent current source is what? Input. Independent current source is what? Input. IA is what? One of the inputs. Another independent voltage source is what? The second input. And then we have one more independent source, that is what? VC. So how many independent sources are driving the circuit? 3 independent sources are driving the circuit. 3 independent sources driving the circuit. That means what? We have a linear circuit driven by 3 inputs. We have what? A linear circuit driven by 3 inputs in the form of what? IA, VB and VC. And the output quantity of interest is what? The current in this particular branch or in this piece of wire, which is what? I0. So this I0 is what? Output. First of all, this is what? A linear system. And the second point is what? That this is what? Like the first input. This is what? The second input. This is what the third input, input 1, input 2 and input 3. And this I0, it is what the single output. And then some table is given. Look at the table. The three inputs are mentioned in the first three columns, okay? Input 1, input 2 and input 3. And fourth column is what? The output. And look at the first case, IA on, VB on, VC off. On means what? It is active. On means what? That source is present and it is what? Active. Off means what? That source, you have made it 0. Yes, so in the first case, this current source and this voltage source both are kept active. VC is off, that means what? You make this voltage source a short circuit. Then the resulting current in this short circuit is what? 20 amps. I hope the first entry in the table is clear. These two sources active, this source 0, output is what? 20 amps. Then in the second case, IA is what? On or active, VC is what? On or active, VB, that is what? This input, you make it 0. Again the output in the second case is what? Minus 5 amps. And in the third case, all three sources are on. That means all three sources are present and they are what? Active. In that case, the output is what? 12 amps. So these are the three cases, okay? So given these three cases, the question is what? Find the output. I0 is what? Output. Find I0, that is what? The output. If IA and VC are doubled. If IA and VC are, that means what? IA becomes 2IA. If you see, again, linearity. If IA becomes 2IA, see, due to IA alone, you will get some output. Yes or no? Due to IA alone, you will get some output. Now if IA becomes what? 2 times, even the corresponding output becomes what? Twice. If IA becomes 2IA, the corresponding output due to IA alone also will become what? Twice. So here IA is what? Doubled. So the corresponding output will get doubled. VC is also what? Doubled. Even the corresponding output due to VC alone will also get doubled when VC becomes what? 2VC. And then VB is what? Reversed. VB is what type of input? It's a voltage source. Voltage source reversed. It means what? Polarity of the voltage source will be interchanged. Plus becomes minus, minus becomes plus. In other words, VB becomes what? Minus VB. Yes or no? Voltage source reversed. It means what? The value of voltage becomes negative of what it is initially. So VB becomes what? Minus VB. Let us say due to VB alone, you get some output. Due to VB alone, if you get some output, now when that VB becomes what? Minus VB, even that output becomes what? Negative of its initial value. You understood? So what is happening here? IA becomes what? 2IA. VC becomes what? 2VC. VB becomes what? Minus VB. And when all these three modified inputs are acting at the same time, what is the resulting output that you have to find? Please try. Take 3-4 minutes and come up with the answer. I hope the question is clear. Okay. A couple of students are saying it is minus 27. I believe it is correct. Please look at the screen, all of you. Let's find the output when IA and VC are doubled and when VB is what? Reversed. You see, let the output due to IA alone, listen carefully, let the output due to IA alone, that is what? The first input, when that is the only input which is active, and when the other two inputs are made 0, let the corresponding output be some Y1, okay? So due to IA alone, let the output be Y1. Due to VB alone, let the output be Y2. And due to VC alone, let the output be Y3. Now come back to the table. In the first case, IA is what? On, VB is on or active, VC is what? Off. If IA is on, you will get what? Y1. If VB is on, you will also get Y2. If VC is what? Off, you won't get Y3. So the net output will be what? Output due to IA plus output due to VB. Yes or no? Output due to IA plus output due to VB. Output due to IA is what? V1. Output due to VB is what? Y2. Add the two outputs. In other words, y1 plus y2. y1 plus y2 will be equal to what? 20. That is like the first equation. Look at the second case. IA is on. If IA is on, due to IA alone, you will be getting what? y1. Fine. VB is what? Off. VB is off, you won't get y2. VC is on. If VC is on, due to VC alone, you will get what? y3. So in the second case, you are going to get both y1 as well as y3. So the net output will be what? y1 plus y3. And what is that value of output in the second case? It is minus 5. y1 plus y2 is what? 20. y1 plus y3 is what? Minus 5. From these two, let us also look at the third case. What is the third case? All three are present. That means what? The net output will be what? Sum of the individual outputs. y1 plus y2 plus y3. y1 plus y2 plus y3 equal to what? 12. Equal to what? 12. Now if you look at the second equation, it is what? y1 plus y3. If you look at the third equation, or if you look at the first equation, y1 plus y2 is what? 20. Now in the third equation, first two terms are what? y1 plus y2. So in place of y1 plus y2, let me write 20. So 20 plus y3 equal to what? 12. So what is y3? It is minus 8. What is y3? It is minus 8. What is y3? It is minus 8. If y3 is what? Minus 8, can't you find y1? Because y1 plus y3 is what? Minus 5. y1 equal to what? Minus 5 minus y3. Already y3 is what? Minus 8. Minus y3 is what? Plus 8. Minus 5 plus 8, which is plus 3. So what did we get for y1? I am getting y1 is what? Plus 3. Again, if you know y1, can't you find y2? Again, take the first equation. So in the first equation, y1 plus y2 is what? 20. So y2 is what? 20 minus y1. 20 minus y1. y1 is what? 3. 20 minus 3 is what? 17. That's all. y1 is what? Plus 3. y2 is what? 17. And y3 is what? Minus 8. These are the individual outputs due to each and every input when it is acting alone. If only IA is present, output is what? 3. If only VB is present, output is what? 17. If only VC is present, output is what? Minus 8. Now coming to the question, IA and VC are doubled. You see, if IA is doubled, due to IA, what is the output? y1. It becomes what? 2y1. Okay? 2y1. Even VC is what? Doubled. Due to VC alone, what is the output? y3. If VC becomes 2VC, then the corresponding output also will become 2 times. It will become what? 2y3. And finally, VB is what? Reversed. I already said the meaning of VB being reversed. VB becomes what? Minus VB. Even the corresponding output will become what? Negative of its initial value. Due to VB alone, what is the corresponding output? y2. VB becomes minus VB. y2 becomes minus y2. That's all. The answer is what? 2y1 plus 2y3 minus y2. What is 2y1? y1 is what? 3. 2y1 is what? 6. What is 2y3? y3 is what? Minus 8. 2y3 is what? Minus 16. Correct, right? And then minus y2. y2 is what? 17. Minus y2 is what? Minus 17. So as you all said, it is minus 27 amps. So there is direct application of linearity. So if any input gets scaled by some factor, the corresponding output will also get scaled by the same factor. This is true for any linear circuit. So this is pretty much what we should know about linearity and the application of superposition in the context of circuits. I will end the class for now. Tomorrow we will get started with the single most important circuit theorem, that is the Thevenin's theorem. Okay, so tomorrow we shall try to discuss Thevenin's theorem. I'll see you in tomorrow's class. Thank you.